Part 2.
Let's say we have this question. It might look quite complex to you, but it is not really complex. Now we have a mixed fraction multiplying a fraction divided by another fraction. You know, the rule of Bodmas here says you divide before you multiply. So we have to work with this first before we multiply our results by this. So we start by converting all of them from mixed fractions to improper fractions. So we start with this. We go 6 times 1, 6. The result, which is 6 plus 2, that's 8. So we have 8 over 6 times. For this fraction, we have 5 times 4, 20 plus 1, that's 21. That's 21 over 4 over. Then we have 9 times 1, 9 plus 5. That's 9 plus 5, that's 14 over 9. And note, I said earlier, you have to divide before you multiply. So you work with these two fractions first. Then the result, you multiply it by this. So we can write it in this format. We have 8 over 6 times 21 over 4 divided by 14 over 9. So we'll put it all plain or linear. You know, this fraction is linked to this fraction by dividing sign, so you still put it there. Then we divide first before we multiply. And you know, division doesn't mean we just cut out. We change it from division to multiplication. Then you switch the numerator and the denominator of the fraction behind. So we have 8 over 6 times 21 over 4 times 9 over 14. We switch from division to multiplication. Then we switch the numerator and the denominator of the fraction behind. So we have this. Now we can start cancelling out or cutting down. You can take this 4 and this 8, you know. We have 4 in 4, 1, 4 in 8, 2. So you can say 4 in 4, 1, 4 in 8, 2. We can go again, 2 and 6. There's 2 in 2 and there's 2 in 6. We can say 2 in 2, 1, 2 in 6 is 3. Now we brought that down. Then we can go 3 and 21. 3 can go in 21. 3 in 3, 1, 3 in 21, 7. Then we have 7 and 14. 7 can go in 14. 7 in 7, 1, 7 in 14, 2. We are left with 9 and 2. We can multiply everything in the numerator. That's 1 times 1, 1 times 9, that's 9 over 1 times 1, 1, and the result, which is 1 times 2, that's 2. So we have 9 over 2. This is an improper fraction where we have the bigger number on top of a smaller number. We can't leave our final answer as this. We have to divide 2 by 9. The result will be the whole number. Then the remainder will be on top of the 2. So 2 in 9 is 4. That's 4, because 2 times 4 is 8. Then the remainder is 1, because 9 minus 8 is 1. So 9 minus 8 is 1. We have our remainder here. Then we have our 2 here. And this is our final answer. This question is a fraction question with an element of Bodmas in it, where we have two signs. We have addition and we have division. Now in Bodmas, we are meant to divide before we add. This is a unique question where we can put it under operations. Since we have a numerator and a denominator, we are having two mixed fractions on our numerator linked with addition. We have to add them first and make them 1 before we can divide. So this is a unique case question where we have to add before we divide, since there are two numbers at the numerator level. And if we were to divide, we have to divide each mixed fraction by the denominator. You divide this by this and also this by this, then we now add it together. It's going to be a little bit complex, so therefore we have to add them first before we divide. So if you have a unique case like this, you have to either add. If it were to be subtraction, you subtract first before you divide. This is at the numerator level. This is a unique question, and that's why we're having this question. We convert everything from mixed fractions to improper fractions to make our work easier. So we have it as 2 times 1, 2 plus 1, 3. So we have this as 3 over 2 plus. We have 3 times 1, 3. 3 plus 2, that's 5. So we have it as 5 over 3 all over. We have 10 times 1, 10. Its result, which is 10 times 2, that's 12. So we have 12 over 10. We therefore go on to add this first. So we find the LCM of 2 and 3. Rule our LCM line. LCM of 2 and 3 is 6. Then we go 6 divided by this 2 is 3. The result, which is 3 times this 3, is 9. So we have this as 9 plus 6 divided by this 3 is 2. Then the result, which is 2 times 5, that's 10. Note that the fractions we've added is this ones. So we still have this one below. So we rule our big line. Then you have 12 over 10 at the bottom. So we have 9 plus 10. 9 plus 10 is 19 over 6 divided by 12 over 10. We've added these two fractions and we've gotten 19 over 6 divided by 12 over 10. This might look a little bit complex, but we have 19 over 6 divided by 12 over 10. We have to do it in that order. So we have 19 over 6 divided by 12 over 10. We can then turn the division sign into multiplication, then flip the fraction behind. So we have 19 over 6 times 10 over 12. We flip this. The 10 now goes to the top, the 12 comes to the bottom, which is equals to, we can cut down, we can say 2 here, 3, 2 here, 5. We've done the usual where you cut down. Then you can say 19 times 5, then 12 times 3, since we can't cut any other thing. For the numerator, the upper value, 19 times 5 is 95, and 3 times 12 is 36. This is an improper fraction where 36 is carrying 95, and 95 is bigger than 36. So we can't leave our answer this way. You have to convert it to a mixed fraction, which is 2 whole number 23 over 36. 36 can only go in 95 2 times. Then the remainder is 23. Then you still have your over 36, which is our final answer. A quick summary is that we had to convert all these fractions from mixed fractions to improper fractions. Then we add these two first. The result, we now divide it by this fraction. Then we get our final answer. We have another question with an element of Bodmas in it, where we have both multiplication and division. And just like the previous question, we have a numerator and a denominator. And not minding that division comes before multiplication, we have to multiply first to make sure we resolve our numerator or the number on top into one value before we divide. To solve this question, we have to convert all these mixed fractions into improper fractions. Then we multiply, and finally we divide by the denominator or the number below. So we'll start by converting them first. We have 1 times 6 is 6 plus 2. 6 plus 2 is 8. So we have 8 over 6 times. We have 4 times 5 is 20 plus 1. 20 plus 1 is 21 over 4 over 9 times 1 is 9. The result 9 plus 5. 9 plus 5 is 14 over 9. We can look at this and we can cut to lowest term, the numerator. 2 can go in both 6 and 8. So we go 2 here, 3, 2 here, 4. Then 3 can still go in this 3 and 3 can still go in this 21. 3 here, 1, 3 here, 7. Then we have 4 here and 4 here. 4 can still go in 4, 1, 4 here, 1. We're done cutting down. So we have 1 times 7 is 7 over 1 times 1 is 1. So we have 7 over 1 over 14 over 9. At this point, we have 7 over 1 divided by 14 over 9. We know this is separate and this is another separate fraction, and they are linked by division sign. So we have it as 7 over 1 divided by 14 over 9, which is also equals to 7 over 1 times 9 over 14. At this point, we can cancel out 7 here, 1, 7 is 14 is 2. What we have left is 9 times 1, 9, 2 times 1 is 2. We have 2 over 9. This is an improper fraction where you have 2 at the bottom, 9 on top. That's 2 is carrying 9. We convert it from this improper fraction to a mixed fraction. 2 times 4 is 8. So we know 2 in 9 is 4 remainder 1. So the result is 4 whole number 1 over 2. In summary, when you have a question like this, first thing you do is convert these mixed fractions to improper fractions. Then you work with the numerator first. In cases like this, even if you have addition here or subtraction here, you have to solve for the numerator first. Then you now divide the answer you got from the numerator by the denominator.